In the vast stillness of space, Earth drifts like a fragile drop of water, suspended in an endless ocean. Around it, comets and asteroids wander, icy relics of creation, fragments of stone and dust left over from the birth of the solar system. Most remain far away, circling harmlessly in distant belts. But some break free. They fall inward, pulled by the gravity of the sun, rushing on paths that can cross the orbit of our small and vulnerable world. For a planet like Earth, these encounters are not myths. They are history, etched in the scars of craters that still mark its surface. Each one is a reminder of how easily destruction can come from above. And yet, Earth has survived. Life has flourished. Across billions of years, oceans have endured, forests have grown, and civilizations have risen under skies that might have fallen silent long ago. The reason for that survival may lie not only in Earth itself, but in a distant guardian, a planet so massive that it bends the architecture of the solar system around it. Jupiter, the giant of gas and storms, a world more than 300 times the mass of Earth, exerts a gravitational pull that extends far beyond its swirling clouds. It is a planet that consumes, deflects, and redirects, a silent protector that has shaped the fate of every world that orbits closer to the Sun. It does not act with intention. It does not choose. But time and again, the mathematics of gravity have made Jupiter a shield. Without it, Earth might have faced storms of comets and asteroids, so frequent, so violent, that life could never have taken root. With it, we were given time. Time enough for rivers to flow, for life to rise, for human eyes to one day look back and ask, how many times has Jupiter saved the Earth from destruction? Long before humanity understood what Jupiter truly was, it stood out in the night sky as a wandering beacon. Ancient stargazers tracked its path across the heavens, watching as it drifted slowly among the fixed stars. To them, Jupiter was not just a bright point of light, it was a god. The Babylonians called it Marduk, the supreme deity of order who tamed the chaos of the cosmos. The Romans named it after their king of gods, Jupiter Optimus Maximus, a celestial ruler whose brilliance commanded reverence. Night after night, it appeared steady, luminous, moving with patient grace through constellations, marking the passage of seasons and generations. But behind those myths, a deeper truth waited to be uncovered. In 1610, Galileo Galilei lifted his small telescope to the sky and turned it toward Jupiter. What he saw forever changed our understanding of the universe. Orbiting around the planet were 4 bright points of light, moving night by night. At first, Galileo thought they were stars, but soon he realized they were moons. Io, Europa, Ganymede, and Callisto, revolving around Jupiter in a miniature system of their own. The discovery was revolutionary. It shattered the ancient belief that everything circled the Earth. As telescopes improved, the enormity of Jupiter came into sharper focus. By the 19th century, astronomers measured its size and mass, realizing it was a giant unlike any other planet. More than 11 times Earth's diameter and over 300 times its mass, Jupiter was not simply another member of the planetary family. It was the anchor of the outer solar system. Its gravity ruled over asteroids, comets, and moons, binding them into patterns that stretched across hundreds of millions of kilometers. The first hints of its influence on Earth's destiny came not from telescopes, but from mathematics. As scientists charted the orbits of comets, they noticed strange deflections, abrupt bends in their paths. Time and again, the culprit was Jupiter. Its enormous gravity tugged on these icy wanderers, altering their trajectories, sometimes pulling them inward, sometimes slinging them outward into the void. The more astronomers studied, the clearer it became. Jupiter was not simply a passive planet drifting in orbit. It was an active player in the celestial dance, reshaping the routes of objects that might otherwise have threatened Earth. And yet, this was not always understood as protection. For centuries, comets were omens of doom, their sudden appearances feared as heralds of disaster. What no one knew was that behind many of their journeys lay Jupiter, orchestrating their paths like a hidden hand. Some were captured, trapped in long, looping orbits that would never touch Earth. Others were hurled away, cast out into interstellar space, never to return. By bending their trajectories, Jupiter became both a gatekeeper and a guardian, shaping the very architecture of the solar system in ways early astronomers could only glimpse. The story of discovery was not only about Jupiter itself, but about Earth's place within a larger cosmic order. Galileo's moons revealed that Earth was not unique in holding companions. The calculations of Newton and Laplace showed that Jupiter's pull reached across space, its gravity not confined to itself, but felt even here on our small planet. With each new century, the picture sharpened. Earth's survival was not only the gift of its distance from the Sun or the stability of its orbit, it was also the product of a distant giant whose invisible hand deflected the debris of creation and quietly reshaped the odds of catastrophe. Jupiter, the wandering star of the ancients, had become something greater, a silent guardian, a planet whose enormity had written itself into the history of life on Earth long before life even began. As the centuries turned, humanity's gaze toward Jupiter grew sharper, and with it, the sense of awe deepened. Astronomers began to chart not only its moons, but its very atmosphere, a swirling canvas of storms and bands that testified to the power of this giant. By the mid-1600s, observers had already marked the Great Red Spot, a storm larger than Earth itself, raging for centuries, with winds that defied imagination. Here was a planet not of solid ground, but of endless gas and turbulence, a world where gravity sculpted storms on scales our skies could never know. And beneath those clouds, hidden from view, lay the secret of its true power, mass so immense that it dominated everything around it. By the 18th and 19th centuries, as the tools of astronomy grew more refined, the role of Jupiter in shaping the solar system began to emerge. The discovery of the asteroid belt between Mars and Jupiter revealed a region where countless rocky bodies circled the Sun but never formed into a planet. Why had they remained fragments, unable to coalesce? The answer was Jupiter. Its gravity stirred the belt like a giant hand in water, preventing the stones from settling, scattering them into resonant orbits where they remained forever fragmented. What might have been another world became instead a swarm of debris, a silent monument to the disruptive might of Jupiter's pull. At the same time, the study of comets grew more precise. Their long elliptical orbits, sometimes stretching far beyond Neptune, sometimes diving perilously close to the Sun, often bore the unmistakable signature of Jupiter's influence. Astronomers traced their paths backward and forward, finding that Jupiter served as both trap and executioner. It could capture a comet, binding it to return again and again, as with Halley's comet, whose periodic visits became part of human memory. Or it could fling a comet outward, hurling it beyond the solar system forever. Each trajectory bent by Jupiter was another silent intervention, another unseen choice that changed the odds of what might one day collide with Earth. It was in the 20th century, with the rise of astrophysics and orbital mechanics, that Jupiter's role as a shield first became clear. Scientists realized that without the giant's presence, the Earth would be far more exposed. In simulations where Jupiter was absent, the inner planets endured far higher rates of bombardment from asteroids and comets. The craters on Earth, the Moon, and Mars already testify to how violent the early solar system had been, but the simulations suggested it could have been worse, catastrophically worse, without Jupiter absorbing, deflecting, or ejecting countless would-be impactors. In this way, the gas giant revealed itself not only as a ruler of orbits, but as a silent protector of fragile worlds. Still, this protection was not absolute. Jupiter's role is double-edged. Its massive gravity can save, but it can also endanger. Some comets that might have remained harmless in the outer reaches were instead nudged inward by Jupiter, their courses altered until they cut across the orbits of Earth and its neighbors. To call Jupiter a shield is to capture only half the truth. It is also a gatekeeper, deciding which wanderers are banished and which are delivered into the inner solar system. For Earth, survival has always depended on this balance, a dance between protection and peril, between salvation and threat. By the late 20th century, humanity's understanding of Jupiter had grown into something both scientific and philosophical. Telescopes revealed its swirling atmosphere in vivid detail. Spacecraft like Pioneer and Voyager flew past, sending back the first close images of its storms and moons. The giant planet no longer belonged only to the realm of gods and myth. It was a world of science, a world that held sway over countless smaller bodies, a world whose silent gravity had shaped the very conditions that allowed life on Earth to endure. And so the story of discovery became more than an account of orbits and masses. It became a meditation on chance. Out of all the possible architectures the solar system might have taken, it was this one, a small, rocky Earth, warmed by the sun, shielded in part by a distant giant, that became reality. Without Jupiter, the probabilities tilt toward ruin. With Jupiter, there was a window wide enough for oceans to remain liquid, for evolution to proceed, for human beings to one day look back and realize the truth. The ancients had called Jupiter a god. Galileo had seen it as proof that Earth was not the center of all things. Later astronomers measured its mass, charted its pull, and uncovered its reach across the solar system. But perhaps the deepest discovery was neither in numbers nor in orbits. It was the realization that without this silent giant, the Earth itself might never have survived long enough to know it existed. The recognition of Jupiter's true role in the solar system was more than a scientific detail. It was a revelation that struck at the heart of how fragile Earth really is. For centuries, astronomers had marveled at Jupiter's size, its swirling storms, and its retinue of moons. But it was only when the mechanics of comets and asteroids were studied in depth that a shocking truth emerged. Jupiter was not simply a distant world of gas and storms. It was a force that had rewritten the history of Earth itself. The shock came with the realization that comets and asteroids are not harmless wanderers. They are bullets in slow motion, crossing paths with planets in ways that can change history in an instant. Earth's surface is scarred with craters that testify to these encounters. Chicxulub in Mexico, where an asteroid struck 66 million years ago and ended the age of the dinosaurs. Tunguska in Siberia, where in 1908, a small fragment flattened thousands of square kilometers of forest. Each of these events showed how vulnerable Earth is to objects from space. But when astronomers ran their calculations forward and backward in time, they discovered something that unsettled them even more. Without Jupiter, there would have been far more such impacts. It was in the 1970s and 1980s that scientists began running the first computer simulations of solar system dynamics. They imagined alternate versions of the planetary system, some with Jupiter, some without. The results were startling. Without Jupiter's immense gravity, the inner planets endured bombardments orders of magnitude greater. Asteroids that Jupiter had ejected into deep space instead lingered, crossing and recrossing Earth's orbit. Comets that the giant had pulled away from harm came rushing inward unchecked. Earth, in such a universe, would not have been a cradle of life, but a target under endless assault. The shock was compounded in 1994, when the comet Shoemaker-Levy 9 provided a dramatic demonstration of Jupiter's role. Astronomers watched as the comet, torn into fragments by Jupiter's tidal forces, slammed into the planet in a series of spectacular impacts. Fireballs larger than Earth rose from Jupiter's atmosphere, and scars darkened its clouds for months. Had Jupiter not intercepted it, Shoemaker-Levy 9 might have continued inward, perhaps toward Mars, Venus, or Earth itself. In that moment, scientists and the public alike were confronted with a staggering image: Jupiter absorbing the blow of a comet that could have been a planetary catastrophe for our fragile world. From that point on, the perception of Jupiter changed. It was no longer simply the giant of storms and moons. It was a guardian, a cosmic shield standing between Earth and destruction. Yet even in this comfort lay another shock. The same gravity that protects Earth could also endanger it. By redirecting asteroids and comets, Jupiter sometimes slung them inward rather than outward. Its shielding was not perfect, not absolute. It was a double-edged sword, saving us in countless instances, yet also raising the possibility of delivering doom. This duality reshaped the way scientists thought about life itself. If Jupiter's presence had filtered and deflected the bombardment of the inner planets, then perhaps it had made Earth habitable. Perhaps without Jupiter, life would never have taken hold, the oceans never allowed to remain stable long enough for complexity to evolve. The giant had been silent, unseen in its work, yet its influence may have determined whether Earth became a cradle of life or a graveyard of endless impacts. The realization carried weight far beyond astronomy. It suggested that our survival was not only the product of Earth's distance from the Sun or the chemistry of its oceans, but also the gravitational presence of a giant that loomed far away in the night sky. For the first time, humanity began to see itself not only as a child of Earth and Sun, but also as a species protected, at least in part, by Jupiter's immense and indifferent gravity. The cometary scars of Jupiter's sacrifice were not only seen in 1994 with Shoemaker-Levy 9. Astronomers soon realized that this was not an isolated moment, but a glimpse into a process that has been repeating for billions of years. Craters on Jupiter's moons told the story with silent clarity. Callisto, Ganymede, and Europa are covered in impact marks, a record of the countless objects Jupiter has intercepted or redirected. These moons are like shields of their own, bearing the evidence of collisions that might otherwise have threatened the inner planets. Every scar on their surfaces is a reminder that Jupiter's gravitational field is a magnet for wandering debris. The shock was not just in the scale of Jupiter's influence, but in the consequences for Earth's past. The early solar system was a violent place, a cosmic shooting gallery of rocks, ice, and dust colliding in chaotic orbits. Earth itself endured a heavy bombardment 4 billion years ago, its surface scarred by impacts so frequent that oceans boiled away and crust melted repeatedly. Yet, the bombardment eventually eased, allowing stability to return. Without Jupiter's gravity sweeping the region clear, absorbing some, ejecting others, that bombardment might never have ended. Earth might never have cooled long enough for life to take root. The very fact of our existence may be traced back to the hidden work of this giant. At the same time, scientists were forced to reckon with Jupiter's dual nature. Computer models showed that the same gravitational hand that clears the solar system can also deliver destruction. Jupiter creates resonances in the asteroid belt, regions where orbital periods line up with its own. These resonances act as gravitational launch pads, slowly destabilizing asteroids and sending them inward toward Earth. The dinosaurs' extinction, triggered by a 10-kilometer asteroid, was one possible consequence of this double-edged influence. Jupiter shielded Earth from countless threats, but it may also have loaded the gun that fired the most devastating shot in our planet's history. This revelation forced a new humility in planetary science. Jupiter was not simply savior or villain, but both. Its gravity was indifferent, obeying no intention. It could just as easily protect Earth as threaten it. The shock lay in the recognition that Earth's fate and life's history had always been entwined with the unpredictable influence of this distant giant. Our survival was never guaranteed. It was a consequence of chance and gravity, of orbits that could as easily have doomed us as preserved us. The idea spread outward into the study of exoplanets. If Jupiter had shaped Earth's history so profoundly, then perhaps gas giants are critical in other planetary systems as well. Some astronomers began to suggest that the presence of a giant planet might be one of the preconditions for life. A cosmic guardian, clearing the debris of creation, might be the silent partner in the evolution of living worlds. If so, then the story of Earth is not unique, but part of a wider truth. In a universe filled with hazards, survival may depend not only on the warmth of a star, but also on the shadow of a giant. Thus, what began as a scientific discovery grew into something larger, a new perspective on existence. Jupiter was not only the largest planet in the solar system, it was the architect of safety, the sculptor of possibility, the indifferent giant whose gravity shaped the path of life itself. The shock of this realization was not in the violence of impacts or the power of orbits, but in the quiet truth it revealed. Without Jupiter, Earth as we know it might never have survived. Once the shock of Jupiter's role had settled, scientists turned to the task of measuring its influence in detail. It was not enough to know that Jupiter shaped orbits. The question became how, and by how much. Astronomers built computer simulations of the solar system, feeding in masses, velocities, and trajectories, then letting the laws of gravity play out over millions of years. What they saw was a cosmic choreography, with Jupiter as the conductor. In these simulations, Jupiter's effect was unmistakable. Its mass dominated the outer solar system, pulling at comets from the Kuiper belt, tugging on asteroids from the belt between Mars and Jupiter, and scattering interlopers from the distant Oort cloud. Some were ejected entirely, flung into interstellar space, never to return. Others were bent inward, their paths drawn dangerously close to the inner planets. The simulations revealed something profound. Without Jupiter, the bombardment of Earth would be relentless. With it, the danger was reduced, though never entirely erased. Jupiter was not a perfect shield, but a filter, deciding which objects passed through and which did not. The observational evidence matched the models. astronomers began cataloging impact craters across the solar system, comparing the surfaces of the Moon, Mars, and the icy moons of Jupiter itself. The data told a consistent story. In regions closer to Jupiter, impacts were more frequent, scars more numerous, evidence of the giant's role as a gravitational magnet. On Ganymede and Callisto, craters overlapped craters, a record of billions of years of collisions absorbed by Jupiter's neighborhood. Earth, by contrast, bore fewer scars, many erased by weather and geology. Yet the relative absence of catastrophic bombardment in recent eons matched the idea that Jupiter had done its work, sweeping away the worst of the threats. The 1994 impact of Shoemaker-Levy 9 remained the most dramatic example. But as telescopes grew sharper, astronomers noticed smaller impacts occurring on Jupiter's surface every few years. Bright flashes in the planet's atmosphere betrayed comets and asteroids striking the gas giant, each one a reminder of how often Jupiter intercepts objects that might otherwise wander inward. Amateurs with backyard telescopes even joined the effort, capturing video of these sudden bursts of light. Each flash was a quiet salvation, a moment when Jupiter once again took a blow that Earth did not have to endure. The investigation reached further with probes. The Galileo spacecraft, orbiting Jupiter in the 1990s, studied its moons and measured its immense magnetic field, which itself traps streams of charged particles. The Juno mission, arriving in 2016, dove deep into Jupiter's atmosphere, revealing the depth of its storms and the structure of its core. These missions were designed to study Jupiter as a world. Yet their data also reinforced its role as a system shaper. Jupiter was not an isolated sphere, but a gravitational engine, its reach extending millions of kilometers, binding moons, altering asteroids, and influencing the solar system's architecture in ways that rippled all the way to Earth. As the data accumulated, a picture of balance emerged. Jupiter was not purely a guardian, nor purely a threat. It was a force of probability. By ejecting most comets and asteroids, it reduced Earth's exposure dramatically. But by altering the orbits of others, it occasionally increased the risk. The balance was delicate, the outcomes unpredictable in detail, but inevitable in pattern. For Earth, survival depended not on absolutes, but on odds. And Jupiter, indifferent and immense, tilted those odds just enough in our favor to make life possible. The deeper scientists looked, the more philosophical the investigation became. Was Earth lucky, or was Jupiter's presence the reason life could exist at all? Did the solar system's architecture emerge by chance, or does it reveal something about how planetary systems form everywhere? Each crater, each simulation, each comet deflected was not only a data point, but a reminder that Earth's story is inseparable from Jupiter's. Our planet's safety, its history, even its ability to host observers at all, may be the shadow cast by a giant we only now begin to fully understand. The effort to quantify Jupiter's guardianship did not stop at broad simulations or dramatic cometary collisions. Scientists wanted precision. How many threats has Jupiter truly removed from Earth's path? How much of our survival is owed to its presence? To answer this, astronomers refined their models, adjusting variables one by one. They asked what the solar system would look like if Jupiter were twice its current mass, or half, or absent altogether. The answers painted a spectrum of alternate realities, each more unsettling than the last. In a universe without Jupiter, the inner solar system became a shooting gallery. Comets from the Oort cloud, billions of icy bodies on the edge of the sun's influence, would fall inward unchecked. Without Jupiter to deflect or eject them, The number of Earth-crossing comets increased by factors of 10 or more. The asteroid belt, left unperturbed, became unstable over long periods, releasing waves of rocky debris toward Earth. In such a world, the size of the dinosaur killer would not be rare. They would be common, perhaps once every few million years. Under such conditions, complex life would struggle to survive, and civilizations like ours might never arise. At the other extreme, if Jupiter were larger, say twice its current mass, the results were paradoxical. While the giant would eject even more comets and asteroids from the solar system, it would also destabilize the inner planets themselves. Resonances created by a more massive Jupiter could tug relentlessly on Earth's orbit, nudging it into chaos over billions of years. If the balance shifted too far, Earth could be cast into an eccentric orbit. Its climate torn between extremes of heat and cold, or even ejected entirely from the solar system. The simulations showed that safety is not simply a matter of more protection, but of balance. Jupiter is the right size, in the right place, to both shield and preserve. Observational data reinforced these models. Astronomers studied the distribution of comets, dividing them into families named for the regions Jupiter controlled. Jupiter family comets, with orbits shaped by the giant's gravity, formed a distinct population that frequently passed through the inner solar system. Many of these comets had once traveled on long elliptical orbits, only to be reshaped by close encounters with Jupiter. Some were tamed into shorter, less dangerous paths. Others were hurled outward entirely, never to return. Earth's skies and its long-term safety were being curated by a planet hundreds of millions of kilometers away. The moons of Jupiter told the same story, though in silence. Europa, with its cracked icy shell hiding an ocean beneath. Ganymede, larger than Mercury and scarred with ancient lines. Callisto, pockmarked with impacts billions of years old. These moons are not only worlds in their own right, but also witnesses. Their battered surfaces testify to the endless flow of comets and asteroids caught in Jupiter's pull. Each crater on Callisto is a record of something that might, without Jupiter, have wandered inward toward Earth. Each scar is an act of absorption, a moment when the solar system's most massive planet served as a cosmic shield. Even small-scale observations strengthened the case. In 2009, astronomers spotted a fresh impact scar in Jupiter's atmosphere, likely caused by a rogue asteroid. In 2010, amateur astronomers in Australia recorded flashes from another object striking the giant. Year after year, the gas giant reveals itself as a target that intercepts debris too numerous to count. Each flash of light, each scar in the atmosphere, is another moment when Jupiter bore the brunt of a collision that might otherwise have threatened us. As scientists piece these strands together, a deeper truth emerged. Earth's stability is not an accident. It is the result of a system shaped by giants. Without Jupiter, life as we know it would be improbable. With Jupiter, survival became possible. The giant's influence is not a guarantee. It is a tilt of the odds, a rebalancing of the scales. Earth is still vulnerable, but less so. Its history has been punctuated by catastrophe, but not overwhelmed by it. And that difference between occasional disaster and unending ruin may be the reason there are minds here to ponder the question at all. The investigation of Jupiter's role did not end in certainty. It ended in perspective. It revealed a solar system not as a random assortment of worlds, but as an interconnected system where the fate of one planet is bound to the gravity of another. For Earth, that connection is existential. The oceans, the forests, the rise of civilizations, all unfolded in the shadow of Jupiter. Every calculation, every crater, every comet traced backward whispers the same truth. Earth has always been more fragile than it seems, and its survival has always depended in part on the unseen hand of a distant giant. The story of Jupiter as a savior of Earth carried with it a paradox that became harder to ignore. For while the gas giant had shielded our world countless times, the same gravity that served as a protector could also turn into a weapon. The deeper astronomers studied Jupiter's influence, the more they realized that it not only absorbs or ejects dangerous bodies, it could also redirect them, bending their paths not away from Earth, but straight toward it. This was the deepening of the mystery, that the same planet credited with preserving life could in a different moment conspire in its destruction. The asteroid belt itself is a monument to this double-edged role. Positioned between Mars and Jupiter, it contains millions of rocky fragments that never coalesced into a planet because of Jupiter's constant gravitational stirring. But Jupiter's influence on this belt is not passive. Within it lie regions called Kirkwood gaps, empty spaces where asteroids have been pulled away by orbital resonances with Jupiter. These resonances act like gravitational traps, amplifying small nudges into great shifts, pushing asteroids onto new trajectories that sometimes cross Earth's orbit. Without Jupiter, the asteroid belt might have formed a stable planet. With Jupiter, it remains an unstable reservoir of potential threats, a supply line of cosmic bullets aimed on occasion at Earth. The same paradox exists with comets. Jupiter's immense gravity shepherds many comets into shorter, more predictable paths, creating the family of objects known as Jupiter family comets. On one hand, this reduces their danger, taming orbits that might otherwise bring them into chaotic, high-speed encounters with the inner planets. On the other hand, the very act of drawing them inward increases their presence near Earth. Jupiter delivers some comets into the very neighborhood it also protects. In the impact statistics, the result is not a shield of certainty, but a balance between reduced frequency and redirected peril. This balance has left its scars on Earth. The Chicxulub impact, which brought an end to the dinosaurs, may itself have been the result of Jupiter's hand. Some scientists propose that a fragment of a long-period comet, disturbed by Jupiter's gravity, was sent inward to strike Earth 66 million years ago. If true, then Jupiter was both savior and executioner, the same force that cleared countless threats, yet also the one that set the stage for the extinction that changed the course of evolution. Without that impact, mammals might never have risen to dominance. Without that dominance, humanity might never have appeared. Thus, Jupiter's paradox deepens. Destruction and protection are woven together into the same gravitational story. The mystery grew further as scientists began to consider how delicate Earth's survival truly is. Simulations revealed that even small changes in Jupiter's orbit or mass would alter the fate of our planet dramatically. A slightly closer Jupiter would destabilize the asteroid belt even more, sending waves of debris inward. A slightly farther Jupiter would reduce its shielding effect, leaving Earth exposed to cometary storms. Its very position, halfway between the inner and outer solar system, is part of the reason Earth has been able to endure. Too near, too far, too massive, too light. Each alternative paints a picture of a world far less hospitable than our own. The escalation of the mystery lay in this realization. Jupiter is not only Earth's protector, but also a shaper of fate. Its gravity writes both salvation and destruction into the same script. Its influence balanced on the edge of probability. It is a cosmic gatekeeper, but one that is indifferent, obeying only the equations of gravity. Whether it saves or destroys is not the intention, but the consequence, the outcome of orbits that intersect or diverge. For humanity, this indifference is both a comfort and a terror. Jupiter has spared us from countless catastrophes, yet it has also loaded the dice that make others inevitable. And so the mystery deepens. Jupiter is not simply the reason Earth survives. It is also the reason Earth has known catastrophe. It has shaped not only the odds of life's endurance, but also the very path of evolution. The Earth that we know, the humanity that looks upward to study the skies, exists because Jupiter both saved us and doomed us in different moments. The protector is also the executioner, and the line between them is thinner than we once imagined. The paradox of Jupiter's dual nature forced scientists to look more carefully at the fragile balance of the solar system. As their simulations grew more advanced, new layers of unease emerged. Jupiter was not simply a barrier between Earth and destruction. It was also a sculptor of chaos. When they ran models with slight adjustments, changing Jupiter's orbit by a few percent, or shifting its mass, they found that the entire system unraveled. Planets wobbled in unstable paths, asteroid orbits shifted unpredictably, and comets fell inward in storms that would have sterilized Earth many times over. The lesson was clear. Jupiter does not just exist, it exists in the right place, at the right size, at the right moment in cosmic history. A delicate alignment stands between life and annihilation. This realization escalated the mystery. Was Earth lucky, or was this balance inevitable? Did Jupiter's presence make our planet's story possible? Or are there countless other systems where the absence of such a giant prevented life from ever emerging? Each crater on Earth seemed to whisper the same contradiction. We are here because we were spared. But we were also shaped by destruction. The very extinction of the dinosaurs, catastrophic beyond measure, opened the door for mammals, and eventually for humans, to thrive. Jupiter's hand may have delivered that impact. If so, then our existence is tied to both mercy and cruelty, to the same gravitational law that saves and condemns without distinction. The deeper astronomers looked, the more they saw Jupiter not as a singular protector, but as a pivot point for Earth's destiny. Its resonances in the asteroid belt, regions where orbits line up and amplify, remain sources of potential threat. Some asteroids locked in these resonances are slowly nudged over millions of years into paths that intersect Earth's orbit. The giant does not simply shield, it sets up lawn paths, slow games of chance that can deliver devastation after eons of silence. Each near-Earth asteroid cataloged today carries with it the possibility that it was once a harmless body in the main belt, drawn inward by Jupiter's quiet, patient pull. Even beyond our solar system, the mystery deepens. As astronomers discover thousands of exoplanets orbiting distant stars, they search for worlds like Earth. Yet again and again, they find giants like Jupiter. Some are closer to their stars, hot Jupiters that scorch their systems. Others are farther out, massive guardians whose presence may stabilize their inner neighbors. The pattern suggests that our story may not be unique, that gas giants are architects of fate in planetary systems across the galaxy. And yet, the complexity of their roles mirrors our own Jupiter's paradox, protector and destroyer in the same breath. What this means for life elsewhere is profound. If Jupiter has both shielded and endangered Earth, then perhaps other civilizations face the same balance. Perhaps the survival of life in the cosmos is always negotiated through giants like these, silent arbiters of probability, whose gravity decides which planets endure and which are erased. In this light, Jupiter is not simply a planet. It is a universal archetype, a reminder that safety is always temporary, always conditional, always fragile beneath the weight of cosmic motion. The escalation of the mystery is not in numbers alone, but in meaning. Earth is not safe simply because it is distant enough from the sun, or because it has oceans and an atmosphere. It is safe because of a giant that looms hundreds of millions of kilometers away, a planet that bends the destinies of asteroids, comets, and worlds alike. And in its shadow lies the truth that our existence is always precarious. At any moment, Jupiter could send another comet our way, rewriting history again. At the same time, it may already have saved us 1,000 times over. The protector and the executioner are the same, and Earth's fate has always been balanced on that razor's edge. As scientists traced the paradox of Jupiter's role, their work naturally expanded into speculation. If this massive world had shaped Earth's history, then what might it mean for life? Not only here, but across the cosmos. And what would the solar system look like if Jupiter had been different, larger, smaller, or absent altogether? The theories that emerged were not casual guesses, but careful explorations built on models, mathematics, and comparisons with distant planetary systems. The first line of speculation was simple. What if Jupiter did not exist? Without the gas giant's gravity, the asteroid belt might not have remained a belt at all. Freed from Jupiter's stirring, the fragments of rock and dust could have merged into a planet, perhaps a world the size of Mars or even Earth. At first glance, such a planet might have added richness to the solar system, another sibling world orbiting the sun. But the truth would be darker. Without Jupiter's enormous gravity to eject comets and asteroids, Earth would have been subjected to far more impacts. Some simulations suggest that without Jupiter, bombardments could have been so intense that complex life never had the chance to arise. The oceans might have been vaporized again and again. The fragile beginnings of biology might have been erased before they had time to evolve. In this view, Jupiter's very presence was a prerequisite for life. Its gravity brought Earth the stability it needed to grow. Another speculation asked, what if Jupiter were smaller? A planet of only half its mass would lack the same sweeping power to eject comets from the Oort cloud or asteroids from the belt. More would slip through, more would cross Earth's orbit, and the rate of catastrophic collisions would rise. Perhaps Earth would still host life, but its timeline would look different, slower, more fragile, marked by repeated resets after impacts that wiped out emerging complexity. Civilizations like ours, with thousands of years of continuity, might never have formed. Life might still exist, but in simpler forms, never given the stability needed to reach higher intelligence. On the other hand, what if Jupiter were larger? Twice its current mass? Or 3 times? Here, the speculations grow more complicated. A larger Jupiter would eject even more debris, leaving the inner solar system cleaner and safer. But the price would be instability. Its gravitational resonances would grow stronger, tugging at the asteroid belt with more violence, destabilizing orbits that otherwise remained quiet. Even Earth's orbit could become less secure, nudged slowly into eccentricity over billions of years. In such a scenario, life might begin, but its continuity would be threatened by climate chaos and orbital instability. Once again, balance proved to be the central theme. Jupiter is large enough to protect, but not so large as to destabilize. The theories also turn toward Earth's own past. Was it possible that Jupiter not only shielded our world from destruction, but also helped deliver the very ingredients of life? Comets, rich in water and organic molecules, are thought to have played a role in seeding Earth with the building blocks of biology. Some models suggest that Jupiter, by nudging comets inward, may have guided these icy messengers toward Earth. If true, then Jupiter was not only a protector, but a midwife, ensuring that water and organics reached our young planet. It both cleared away the majority of dangerous objects and directed just enough toward Earth to deliver what life required. Speculations stretched outward as astronomers studied other stars. Many exoplanetary systems revealed giants of their own, gas worlds orbiting at various distances. Some clung close to their stars as hot Jupiters, while others drifted in orbits reminiscent of our own Jupiter. Scientists asked, are such giants necessary for life? Do they serve as guardians, filtering impacts in distant systems the way Jupiter does here? Or are they destroyers, destabilizing worlds that might otherwise have thrived? The answer remains uncertain, but the pattern hints that Earth's story may not be unique, that somewhere else, life might owe its survival to a distant giant bending gravity in its favor. In all these speculations, the theme was constant. Earth's fate is not only its own. Our oceans, our forests, our civilizations, all depend on a planet hundreds of millions of kilometers away, a world of storms and gas whose presence has shaped everything we know. And while the details may remain debated, the conclusion grows clearer with every study. Without Jupiter, Earth would not be what it is. Speculation about Jupiter's role in Earth's story grew bolder as scientists looked at the delicate interplay of chance and necessity that defines the solar system. One theory asks not only how Jupiter has shielded Earth, but how it may have sculpted the very conditions for life by controlling the delivery of water. In the early days of the solar system, when the Earth was still young and hot, its surface too molten to hold oceans. The water we now know may have come from icy bodies born far beyond the sun. Many of these icy wanderers were guided inward by Jupiter's immense gravity, sent into the inner solar system on altered paths. Some struck Earth, bringing with them frozen water and organic molecules. Others missed, continuing on their journeys or breaking apart into streams of dust. In this way, Jupiter may not only have reduced the number of destructive impacts, but may also have enriched Earth with the very resources that made it habitable. Another line of speculation reaches further into cosmic evolution itself. If Jupiter's presence was necessary for Earth's stability, then perhaps the same rule applies to other star systems. Life may not simply require a rocky world in the habitable zone of its star, with warmth and liquid water. It may also require a giant, a distant guardian, whose mass reduces the frequency of catastrophic impacts. Without such guardians, complex life may be rare, constantly interrupted by cosmic disasters. The question then becomes profound. Are civilizations across the galaxy born not just from stars and oceans, but also from giants like Jupiter that never know or intend their role? If so, then our existence is part of a deeper pattern of planetary architecture, a cosmic law in which gravity writes the odds of survival. There are also theories that invert the comfort of Jupiter's guardianship, painting it as a double-edged partner. Some astronomers argue that without Jupiter's gravitational resonances stirring the asteroid belt, Earth might have experienced far fewer mass extinctions. Life, in this view, might have evolved more smoothly without repeated interruptions. The impact that ended the dinosaurs' reign is the most famous example, a catastrophe that cleared the way for mammals and ultimately humans. Without Jupiter's influence to send such a body inward, evolution might have taken another path entirely, one in which intelligent beings like us never appeared. Thus, Jupiter may not only have saved Earth, but also destroyed it enough times to shape the trajectory of life itself. Its role is not simply protective, but creative, setting the conditions for change by occasionally delivering extinction. Some theories stretch into philosophy, asking whether Jupiter's placement and size are the result of cosmic chance or something deeper. The giant exists at just the right distance to serve as a filter, just the right mass to stabilize but not destabilize. Is this alignment a coincidence in an infinite universe filled with countless arrangements? Or does it hint at a principle that life requires giants, that habitable worlds must be paired with worlds of immense gravity? If this is true, then the search for life beyond Earth must include the search for Jupiters. Without them, the odds of survival may be stacked against fragile worlds, no matter how perfect their distance from their star. Finally, there is speculation that stretches into the far future. Jupiter will not remain unchanged forever. Over billions of years, as the Sun expands and ages, the dynamics of the solar system will shift. Jupiter's role as a guardian will change with it, perhaps drawing new comets inward or scattering them outward differently than before. If humanity survives into those distant eras, our relationship with Jupiter will remain essential, for it will continue to shape the pattern of threats that reach Earth. The giant, silent, and storm-laden will still be at work, writing our future in the same invisible gravity that has written our past. Taken together, the theories and speculations do not give a single answer, but a constellation of possibilities. Jupiter is a protector, but also a destroyer. It is a shield, but also a hammer. It is a planet that has preserved life and extinguished it, both through the impartial law of gravity. And yet, through all the complexity, one theme endures. Without Jupiter, Earth's story would be unimaginably different. Whether life would exist at all, or whether it would have followed a path that never led to us, remains unknowable. But what is certain is that the giant has always been there, shaping, guiding, threatening, and saving, a silent architect of our world's fate. To understand Jupiter's role, not only as a planet but as a cosmic guardian, scientists have turned to tools that extend human sight and deepen human patience. It is one thing to theorize about Jupiter's influence, but another to measure it in action. Comets bent in their courses, asteroids shifted from their paths, impacts that reveal the planet's unseen labor. Each tool, from telescope to spacecraft to computer simulation, has been designed to pull evidence from silence, to reveal the invisible hand of gravity at work. The most direct tools are telescopes, both on Earth and in orbit. Instruments like the Hubble Space Telescope have watched Jupiter closely, capturing the aftermath of collisions like those of Shoemaker-Levy 9 in 1994. Hubble's images of the black scars spreading across Jupiter's clouds were more than photographs. They were records of an event that showed Jupiter intercepting a world-killing threat. Later, amateur astronomers with backyard telescopes detected flashes in Jupiter's atmosphere, brief moments when smaller asteroids struck, their fiery signatures recorded as sudden bursts of light. These observations confirmed that impacts are not rare, but ongoing, and that Jupiter continues to absorb debris that might otherwise one day have crossed Earth's path. Meanwhile, spacecraft provided intimacy that telescopes could not. Pioneer 10 and 11, followed by Voyager 1 and 2, flew past Jupiter in the 1970s, sending back the first close images of its storms and moons. The Galileo spacecraft orbited Jupiter in the 1990s, studying its system for years. And now, Juno, launched in 2011 and arriving in 2016, loops around the giant in a highly elliptical orbit, peering beneath its clouds with instruments designed to probe its gravity, magnetism, and structure. Juno's measurements reveal not only the depth of Jupiter's storms, but also the intricacy of its gravitational field, allowing scientists to model how its mass distribution tugs on comets and asteroids passing nearby. These missions have shown that Jupiter is not a monolithic ball of gas, but a dynamic, layered giant whose gravity is as complex as its atmosphere. Another tool lies in the computer simulations that extend observation into timescales beyond human reach. Using supercomputers, scientists can map millions of years of orbital evolution, running scenarios where asteroids drift, comets fall inward, and Jupiter reshapes their fates. These simulations do not produce certainties, but they reveal patterns, like the way Jupiter's resonances in the asteroid belt slowly destabilize orbits, or the way its presence prevents a flood of comets from sweeping through the inner solar system. Without simulations, the subtle, slow hand of Jupiter would remain invisible, hidden behind spans of time far greater than any human could witness. And then there are the planetary defense networks, modern efforts to map every object that might one day cross Earth's orbit. Telescopes like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona scan the skies nightly, cataloging near-Earth asteroids. These programs are not looking at Jupiter directly, but their data often confirms its influence. Many near-Earth objects trace their chaotic journeys back to resonances with Jupiter, which nudge them slowly from stability into danger. In this way, every cataloged asteroid is also a record of Jupiter's unseen role, a gravitational fingerprint written in stone. Taken together, these tools form a picture that is at once scientific and sobering. They show that Jupiter is not a passive background presence, but an active participant in the solar system's dynamics, constantly shaping the environment in which Earth exists. They show it absorbing blows, redirecting wanderers, and maintaining the balance of chaos and order. And they remind us that even with all our instruments, we are still only beginning to understand the full scale of its influence. The task of understanding Jupiter's influence did not end with telescopes and spacecraft. It expanded into global collaborations, precision instruments, and missions still waiting to launch. Humanity has learned that knowing where asteroids and comets are and predicting their paths is not just an exercise in astronomy. It is a necessity for survival. Jupiter stands as the central figure in this work, the unseen partner whose gravity must always be part of the equation. The rise of sky surveys has transformed this search. Projects like the Sloan Digital Sky Survey and the ongoing efforts of Pan-STARRS and the Catalina Sky Survey continuously sweep the skies for faint moving objects. Their discoveries are logged into vast databases, each asteroid's orbit calculated and projected forward in time. Again and again, those orbital paths lead back to gravitational nudges from Jupiter. Some of the most dangerous Earth-crossing asteroids, those large enough to cause global damage, trace their instability to resonances in the asteroid belt. gaps carved out by Jupiter's pull. These surveys, when combined with computational models, show Jupiter's fingerprints scattered across the solar system. Looking further ahead, the Vera C. Rubin Observatory promises to deepen this work. With its legacy survey of space and time, Rubin will create a decade-long movie of the sky, capturing transient events in unprecedented detail. For Jupiter, this means a greater ability to track how comets shift under its gravity, how faint asteroids drift, and how impacts continue to scar its atmosphere. The observatory will not only expand humanity's ability to see, but also to anticipate, to catch in real time the way Jupiter bends the architecture of the solar system. Space missions continue to add new layers of knowledge. ESA's upcoming JUICE mission, the Jupiter Icy Moons Explorer, will study Europa, Ganymede, and Callisto, moons that bear the scars of eons of impacts. Each crater on their surfaces is a record of Jupiter's gravitational reach, a library of collisions preserved in ice and stone. NASA's Europa Clipper will follow, probing the ocean worlds of Jupiter's system, searching for signs of habitability while also mapping their surfaces in exquisite detail. While these missions focus on the moons, they also serve the wider investigation. They reveal how Jupiter has acted as a collector of impacts, a place where the violence of the solar system has been written down across time. The study of planetary defense has also placed Jupiter at the heart of humanity's concerns. Projects like NASA's DART mission, which tested humanity's ability to redirect a small asteroid, are born from the recognition that cosmic threats are real. Yet behind every cataloged asteroid, behind every simulated comet, is the quiet acknowledgement that Jupiter is already performing this work on a far larger scale. Where humanity can nudge a rock by a fraction of a degree, Jupiter can eject an entire population of comets into interstellar space. Where Earth can hope to deflect a small asteroid, Jupiter absorbs objects many times larger without hesitation. In planetary defense, we see ourselves mimicking, in miniature, the role Jupiter has played for billions of years. And yet, the work is not complete. Even with the most advanced tools, we cannot say with certainty how many comets or asteroids Jupiter has spared us from, nor can we fully predict how its gravity will alter their paths in the future. The solar system is dynamic, chaotic, filled with small variables that multiply over time. Jupiter's influence is both stabilizing and destabilizing, protective and threatening. To model it is to wrestle with probabilities, to accept that certainty is beyond reach. Still, each new observation adds clarity. Each flash of light in Jupiter's clouds, each crater on its moons, each orbital path traced back to its resonances is another piece of evidence. They remind us that while our instruments are limited, they are growing stronger, and with them, our awareness. Humanity is learning to see not only what is bright and visible, but also what is hidden, what moves silently, what saves and endangers us without notice. The ongoing testing and the building of new tools are not only about Jupiter, but about our place beneath its shadow. They are acts of vigilance, acknowledgements that survival depends not only on Earth and Sun, but on a distant giant whose storms we can never touch, whose pull we can never escape. And as the tools grow sharper, the story they reveal grows clearer. Earth has never been alone. It has always been shaped, shielded, and sometimes threatened by a planet that does not speak, but whose gravity writes across the history of life. Beneath the stillness of night, when the stars scatter their cold light across the sky, few who look upward think of Jupiter. To the naked eye, it is only a bright wanderer, a planet shining softly in the darkness. And yet, unseen, its gravity has been shaping the fate of Earth since the beginning. It has stood as shield and executioner, protector and destroyer, its storms churning while its mass bends the paths of comets and asteroids that might otherwise have struck us. In its silence lies a story greater than any myth, the story of how a giant, indifferent and immense, has helped write the fragile history of life on this world. Oceans, its distance from the sun or its atmosphere. It is the product of a system, an alignment of forces that includes a planet we do not live on, a planet whose storms we will never stand beneath, but whose presence has given us time. Without it, bombardments might have continued unbroken, erasing life again and again. With it, the odds shifted, not to certainty, but to possibility. And in that possibility, life found room to grow, to endure, to wonder. There is humility in this knowledge. For all our achievements, for all our technologies and cities, we remain a species that owes its survival to the pull of a world hundreds of millions of kilometers away. Jupiter does not care, does not choose, does not protect with intention. It only obeys the mathematics of gravity. And yet, through that indifference, it has preserved us. It has allowed history to unfold, consciousness to awaken, and questions to be asked. In this light, Jupiter becomes more than a planet. It becomes a reminder of how precarious existence is and how beauty and fragility are born from balance. To live beneath its shadow is to know that survival is never absolute, that the odds can tilt with a single comet's path. But it's also to know that we are here, against all the probabilities, to see, to feel, and to reflect. Jupiter, the giant of storms, has written silence into our history. And within that silence, humanity has found the space to live. In the end, Jupiter's story is not about storms or orbits, but about perspective. It reminds us that the universe is not arranged for our safety, and yet, within its indifference, lies the possibility of survival. Life on Earth has been carved out of that possibility, not guaranteed, but permitted, sheltered long enough for oceans to form, forests to spread, and human minds to ask why. To reflect on Jupiter is to see how fragile this permission truly is, and how easily it might have been denied. Every crater on its moons, every scar in its clouds, is a record of blows that never reached us. Each one is a silent testimony that Earth has been spared countless times without ever knowing it. And yet, the very same giant has also delivered catastrophe, the comet that may have ended the dinosaurs, the asteroids it nudges inward to keep the balance unstable. This duality is the essence of existence, protection and danger interwoven, destruction and creation bound together in the same cosmic law. We are not here in spite of these contradictions. We are here because of them. There is a deep philosophy in this realization. To exist in such a universe is to accept that safety is temporary, that balance is delicate, that permanence is an illusion. The forces that preserve us are the same forces that threaten us. Our survival is not written in stone, but in probability, in odds shifted by a planet that neither knows nor cares about the beings who depend on it. And yet, this indifference is not emptiness. It is the condition of awe. It is the backdrop against which human life shines with even greater intensity, brief and fragile, yet luminous against the vast dark. As civilizations look outward, building telescopes, launching spacecraft, and simulating the futures of worlds, Jupiter remains a reminder that the universe is not hostile, nor is it kind. It is simply vast. And within its vastness, giants like Jupiter bend fate in silence. Earth endures its shadows, fragile yet persistent, long enough for us to love, to build, to wonder. The final reflection is not that Jupiter saved us once or 1,000 times, but that it gave us the rarest gift of all, time, to evolve, to imagine, to speak across generations. Time to look upward at the giant itself and realize that our story has always been written in its gravity.